Hi everyone. I have Marko Zovko to my right, and he is a developer that likes the practical things. He likes getting his hands dirty instead of dealing with the theory. He also has a dog named Sparky. So we're going to learn how to build something like Ethereum Plasma from scratch. Please welcome Marko.
So thank you for coming all here. So before I start, just a quick intro. So did anybody research Ethereum Plasma before? Okay, so people know about it. Okay, so I'm going to be talking about how to build something from like Ethereum Plasma from scratch. But the thing is, we first have to realize why do we need Plasma. So the first thing why we need Plasma is because Ethereum network, as we all talk about, is very slow. So we can only process 15 transactions per second, which you all, I assume, heard like 15 times this day. Second thing is, it's cheaper to run and develop applications that don't require gas fees, and Plasma helps with that because it allows end users the option to not use real Ether to execute transactions, and which in the end provides better UX for the end users because it's faster and cheaper for them to use. But the important thing about Ethereum Plasma, it is not part of the whole network, it's just a layer 2 solution, so it's called, which means it's built on top of the existing tools that already exist in the Ethereum. So we're not going to be doing anything concretely or talking about how Ethereum works, but more how can we build something on top of that which would enable us as developers to make something which is hopefully a little bit more usable in the end for the end users. So what is Plasma? So Plasma is currently in the research state, which means that it's basically a framework, which means people are still talking and researching about what's the best way to implement Plasma. When I say people, if you heard about forum @research, there's got category specifically about Plasma, where people are still discussing points for or another implementations, but as far as I understood it, there is still no clear front runner to the implementation of that. There are some test implementations that are trying to implement Plasma for the everyday use, but at least to my knowledge, there is still nothing being done that we can, okay, that's the next thing we're going to use. So another big thing about Plasma, so if we accept the fact, I mean not the fact, but the opinion that it's not still done, it's still in development phase, there are three things that are important to Plasma. First is you need to have a side chain. So that means if you have Ethereum mainnet or whatever net you want, you have to have a side chain that's hopefully faster and cheaper to use for other users. You have to have state commitments, which means you have to transfer data from side chains to main chains somehow, and you have to enable users to enter and exit the network as securely as possible. So the things I was talking about, we have a root blockchain or mainnet which we trust, so it could be Ethereum mainnet. We have a side chain that we created, and where the actual application part and the day-to-day usage is happening. And we have this bridge or operator, basically any application or server or whatever you want, however you want to implement it, which transfers data from side chain to root blockchain, and I mean from root blockchain to side chain and other way back. Oh, sorry. So is there only one way to implement Plasma? There isn't, because like I said, on the link you see in the bottom right corner, there is a whole bunch of theories about and researches about how to best implement Plasma. And front runners, as I at least understood it, are Plasma MVP, Plasma Cash, Plasma Debit. So, for example, if you take Plasma MVP, it's based on a UTXO model, which means so if you have funds on mainnet, you can transfer those funds to sidechain, and those funds are locked in a contract or on mainnet, and you can do transactions on sidechain. And after some time passes, either with periodical state commitments or by you as the end user explicitly wanting to withdraw your funds, you withdraw your funds, but the problem is how do you verify transactions happen on sidechain are valid. And for example, if I pay 5 Ether, put 5 Ether into sidechain, those 5 Ethers are locked in the contract, and when I run some transactions on a sidechain, I send Steve 2 Ethers, I'm left with 3, but on the smart contract on mainnet, it says I have 5 that I inputted. The biggest thing about Plasma is how do we achieve a proof that when sidechain says, okay, Marko has 3 ethers, Steve has 2 ethers, how do we prove without any, with as much security and certainty, okay, that's what actually happened. Plasma Cash, on the other hand, is not used for general funds, but it's used more for unique IDs or tokens, where basically in each block on sidechain or a quarterly that runs Plasma Cash, every token ID has a slot. For example, if we have 5 token IDs that we are using, we have 5 slots, and in this slot, if it's empty, nothing happened in one block on Ethereum or this on the network. And every time something happens, for example, I send a sword, which is an NFT token, to Steve, which has ID of 2 in the second slot, which means ID number 2. I said, okay, sword goes from Marko to Steve, which is different than Plasma. And after that, we have Plasma Debit and a lot of other implementation that you can research or see more about on the link below. But I'm not going to focus on that, because as I started reading the research about Plasma stuff in general, I realized, I mean, smarter people than me are working on this already. I'm not going to be able to research everything about it and find what's the best conclusion. So I want to focus, okay, if I need to make a Ethereum application or decentralized application, I need it to be done by tomorrow, what will I do? But I can go from, I can implement all those stuff that Plasma is talking about, because all that stuff about Plasma is not done yet. It's still in research and in development. So what are we going to do? We are going to hack a little bit, or at least change the rules about how things are going to work, because as I said, focus is on we need something built and done tomorrow, and not waiting for a general theory implementation which would help us to make a formal proofs and proofs that will work with everything, which means we have to take some limitations. So what do we need? We need Plasma contract, like I said before, on the main net. We need some bridge or operator. It could be just a simple Node.js application with Web3, and we need a sidechain which we created, on which the application is being run, and all smart contracts that are needed for application to run. So what does Plasma contract contain? Now, when I talk about this, at least my hacky way of implementing that, I'm mostly influenced by Plasma MVP theory on how they do it. But I omit a few steps because it needs to be done tomorrow. So the first thing we need to know, on mainnet, we need to assign an owner or an operator of the contract, so the operator can update the state when it needs to. The middle bridge has to work somehow, and smart contract needs to know about that. Second thing is, in the smart contract on mainnet, we need to have a list of Plasma blocks. So the transactions I talked about, so if I put 5 Ether on my mainnet, and me and Steve are making transactions on side chain, that data, when it gets updated back to the mainnet, we still have to have at least some way of tracking that data down. And for that, we are going to use Marko roots, so we can prove transactions really happened. And after that, we need to have a list of submitted exit blocks, so which means when someone submits an exit request and wants to pull his money out of the side chain, we need to write it down. And basically, that in the code terms would mean those 4 methods. So first is submit block, which means we are submitting blocks from side chain to mainnet. Deposit, which means we actually just send Ether to smart contract on mainnet, and then operator transfer blocks that funds in a contract and sends them to the side chain. And start exit and challenge exit. Now, start exit means if I want to get my funds back from the previous example, my 3 Ethers back that I have on side chain, I start exit. And after that, because we can't really be sure about validity of sidechain, or how much do we trust the people who run sidechain, we need to be, at least to some point, constantly checking the sidechain for stuff for validity. So is anybody making some foul play? And that's where challenge exit comes into play, which means basically if I put 5 Ether in smart contract on mainnet, those 5 Ether get transferred to sidechain, and I've sent 2 Ethers to Steve, I should have 3. But if I asked for 4, someone should notice that and challenge that exit before something actually, real Ethers are actually transferred to me. And in some suggestions of that research, that time is 7 days, but it all depends on the implementation. So the application smart contract, which is run on the side chain, you write here whatever you want, but it's important that you can take the data and read it by operator and transfer it to the mainnet, which means that operator needs to have at least some way of reading all the transactions, which it should. But first, before we do any of that, we need a private network, and now I researched how to make like a hacky private network, and the easiest way, at least to my knowledge, is using Puppet, the tool from Get, which allows you to build your private Ethereum-based network. If you have, of course, if you have any better ideas, you can let me know, because I'm looking forward to it, because at least to me, this is the most interesting part of the whole Ethereum ecosystem, or at least blockchain. And how do you set up private network? You get 10 servers, you add keys to them, and you install Get and Docker, and you create as many silver wallets as you want. I mean, I'm assuming that we are going to create a proof of authority network. After that, you start local, start Puppet, deploy add starts, boot node, and wallet to at least one node, and you deploy silver nodes to all servers and assign them to silver accounts. After that, you get a nice little add state stats page that says, okay, are the blocks mining, how many peers are connected to the network, and you can see how the network is functioning. So these are just some basic steps, because it makes no sense for me to tell all the details, but I have at the end of the presentation a link for a great blog post about that. And one thing we need to do is, after we deploy all the stuff, we just need to check, are the blocks mining. If the blocks are not mining, the problem could be with did the nodes recognize themselves, but then you have to add nodes manually, which comes to the bridge part, or the middle part of the whole implementation. So it's bridge or operator is basically just when a deposit comes from the mainnet, he looks for it, reads it, okay, he logs that balance in the mainnet, and then sends the data to the funds to the side chain. After that, the point of bridge or operator is that he periodically updates the state on the mainnet, and after that he handles challenges and exit. Now, how I would implement that if I had a week, I would simply make a simple Node.js application that runs WW3.js or Ethereum.js, and as even though Bruno said in the first talk of the day that storing data in logs is a bad idea, I'm going to still suggest that, because we are hacking in the end. Okay, and after that, we are going to, and operator also handles exit and challenges, so it reads events, okay, somebody exported the exit, so I need to check how many funds and what transactions happen on the sidechain for that account, and return those funds if the challenge passes, which means nobody objected to the funds passing. The workflow, I already mentioned most of these things, but one of the things that is probably the biggest problem is it requires users to monitor the sidechain, which means if you want to be completely sure that everything is okay, you still have to manually check the sidechain, because sidechain is proof of authority. You have no way of believing, okay, maybe something changed or not, but you still have to at least sometimes manually check is everything okay. And entering network is, like I said, user deposits money to Plasma contract, operator means fund notification smart contract, so on the side chain. The operator periodically updates states, and exit is the same thing. So user asks for exit, but the only thing is if we're talking about real Ether that we're minting on side chain for users, when they exit, we have to burn those Ether away. The same thing which would we do with ERC20 tokens or whatever, because it needs to have, we can't leave tokens on both networks to live at the same time, because we still haven't solved the way of updating state simultaneously between both side chains, which is a problem that's still currently being solved. And that would be it for me. So here are some useful links. I recommend you the first link on net research. It's a pretty hard read because most of the stuff that goes on there, people are talking about formal proofs, and like, I'm going to be honest, I didn't understand I tried to read everything about it, but I still couldn't grasp the whole thing because there's so many propositions. There's a great topic there called Plasma Roadmap, where is listed like 20 possible implementations, which everybody takes a piece of advice that someone already brought up and tries to add their 2 cents, and people are talking about it, and still nothing is complete, but it's going in a good direction, in my opinion. Second is learnplasma.org. It's more beginner-friendly page where they talk about basic concepts and basic stuff, but it's great info into everything. Plasma.io is the original white paper that Vitalik and Joseph suggested, and here you have a link to Omi's Go Plasma MVP GitHub, where they created a sample implementation of Plasma MVP, which you could check out and try out how it works. And for the test networks, last 2 links are, at least in my opinion, with Puppet, the easiest way to set up private networks. And that's the best talk about. If you have any questions, please.
I know I have like a bunch of questions, but I'm sure you do too. So.
I know, in the simplest way possible, could you explain the difference between a sidechain and a state channel?
In the simplest way, so sidechain runs on actual blockchain. State channel doesn't have to run on a blockchain. It can happen in any way possible.
Okay, but it's what do I get if I decide I'm using sidechains instead of state channels? So what advantage do I have? Because from my point of view, state channels are much simpler, much faster to implement, and don't have a lot of those issues. For instance, if you run a sidechain, I suppose you have to run your own consensus mechanisms of all the problems that come with a sidechain. The state channel is greatly reduced in complexity, but offers a lot of functionality that a sidechain does, at least in my opinion. So the question should be, why should I use sidechains if they are more complex? What do they offer on top of state channels?
To be honest, I have no idea, because I don't have enough experience with state channels to give an answer, because the way I approached this, I started with blockchains, private networks, and it seemed like a way to go, but I will try state channels after that.
Thank you.
Can I help you out on this question?
Yeah.
Right, so in Plasma, or in side chains in general, okay, I'll start with state channels. State channels, you have one limit, and this limit is the parties that can be participants in the state channels. So as long as you add new parties to the state channels, the complexity grows exponentially. So you can think, how do state channels work? You sign everything that everyone does, so basically you sign each other. So with 2 people, it's very easy. When you add 7 people, the complexity of everyone signing to everything starts to grow and grow and grow so much that you actually need to have a consensus algorithm. And so when you want to have any scalability solution that has more than literally 7 people, you can no longer do it with state channels, and you need to have a consensus algorithm. And when you need to introduce a consensus algorithm, then you think about it. You do either POA, you do POS, you do proof of work, and this is a sidechain. So Plasma actually is a scalability solution above state channels. When you use one or the other is a matter of how many actors you are going to have into your scalability solution.
makes sense. Thank you.
More questions? All right, it's my turn. Sweet. So there's my understanding, correct me please if I'm completely wrong, Ethereum Plasma is not fully finalized yet. Is that true?
Yeah.
When it's finalized, is it going to be a big bloated thing because software tends to grow in scope, and for product managers there is this principle of what is the most simple thing that we can ship right now, this idea of ship tomorrow.
Yeah.
Even if it doesn't scale, can we actually release it? So my question is, will Ethereum Plasma be too big? Will it be a thing that is too complex? And do you think that it will actually be something that's simple that people can use?
I think it will actually be, it won't be trivial because every implementation that I've researched so far, it requires some kind of formal way of checking. So if operator sends data, transacts data from the side chains, operator has all these algorithms, Merkle rules, stuff like that it needs to run. But end users, for example, like me or anyone else who start using the app, won't know about any of that. So until the implementation isn't done yet, which is going to be, in my opinion, complex because of all those confirmations, it's not going to be easy to ship it because end users will still going to have to check the network, is it valid, is anything funny happening?
And one big piece too is it financially a good choice? Because if a transaction happens a lot, when you pull it into the main channel, I think you have to pull in all the history of all the transactions that happen within the chain. So then,
yeah, but actually the whole history is not going to be actually transferred to mainnet because that would ruin the point of the side chain. Only the hash Merkle root of those transactions would be transferred to the mainnet. So some small set of data, it could be Merkle root or whatever somebody comes up, that proves, okay, that transaction, this stuff really happened on the side chain, but that's it. Because if we were trying to copy the whole history back to mainnet from side chain, we would still get end users would have a faster using applications, it would be easier for them to use, but the operator would still have to pay the gas fees for transferring all the data back to the mainnet, and we still haven't moved much forward, at least in my opinion.
Yeah. Will the implementation of Ethereum Serenity 2.0 somehow affect the development of Plasma?
I'm actually not quite sure because Plasma, as I understood it, so Plasma is helping other people develop stuff and move as much of implementation or speed away from the mainnet. So it all depends, in my opinion, on how fast Ethereum 2.0 would be. If Ethereum 2.0 means that you can run all those transactions faster, I don't see a need for Plasma, but realistically, in my opinion, it's not going to be that fast, so it's what?
It's money.
It's money.
Money, yeah, it's going to be cheaper.
Yeah, that's the second point. So it still should be better. There should, in my opinion, there would still be need for Ethereum Plasma implementation or something like that, because if we move more part of the blockchain logic of the mainnet, that would be better for you. Another example would be, for example, post office. I like to use that example because post office has whole distribution process, I don't know, 15 steps from when your packet is given to how do you say?
The window.
What?
The window.
The window, okay? And it goes through 15 other steps until it's delivered to your front step. And for the post office, maybe they use blockchain so they can reliably track, oh, I did this, I signed this, and the whole part of the process is important to them. But if they want to output that data to the mainnet, maybe they output just simple data like, okay, we got the packet is sent from shipping, and it's at your doorstep. And they could just take that small data set, which is smaller, and give it back to the mainnet. Or for example, if, I don't know, banks want to run their own blockchains, they would want to hide a lot of data from everyone, I mean, their interest, in my opinion, wouldn't be user experience or speed or cheaper gas, but just to hide data from everyone. But they would still want to have some way to transfer that data or small sets of data to the mainnet, which is probably not being tampered with. Else, there is no point in using blockchains. So I don't know if I answered your question, but thanks, brother in the Bordeaux. Thanks for help again.
Sure.
I have two comments. One, if you fix Croatian post office, I will be extremely grateful.
Yeah.
No pressure. Second, I think that the user experience, so for me, there isn't a problem with technology so much when it comes to blockchain. It's more adoption and these ecosystems. I feel like that's where a lot of the resistance is. For the post office situation, I want to see all 15 steps because then I know that Croatian post is messed up and I can go yell at them. I see the case with banks where they do put more emphasis on privacy. But I guess for the user, is it better to use a sidechain? We did talk about cost, but I think having all this stuff in a faster main chain is better for the end user because they can drill down to a very granular level if they want to. So I guess my question is, from a user's perspective, is Plasma something that the main users will want to use? Is it something that the general user wants as a good thing?
Yeah, I think it is, because it removes, for example, the thing that Oli was talking about at this conference, the user experience when MetaMask window pops up, or you need to sign this transaction, you need to set gas fee or stuff like that. If you run a sidechain, you don't need to care about any of that. For example, if you've been at the last presentation, Nikola was talking about private network and how much Ether or this ETH should be distributed. I mean, we technically don't have to distribute any Ether. We just set Genesis block to 0, set gas price that miners accept to 0, and you don't need Ether. Everything runs as it should. So that's at least one barrier of entry for end user that is going to be removed instantly because of private network. You don't need that. But you can also just pop them a window. Okay, I'm signing this transaction, and that's it. Which is, I believe, going to be a how do you say, main theme of the talk later, if I'm not mistaken. So, yeah, I mean, the end users, in my opinion, should get a faster and more easier experience to work with. Yeah.
I have a question. If we remove the bridge from the picture, can we leave it like that and call it private chain?
With no settlement. I think
Yeah.
it means with the operator in between, what will happen when we remove this, the operator? Is
I mean, I like
Can
the
they
concept,
coexist?
Yeah. And if I say, okay, I don't care about the main network, I don't want to go there, I want to leave it at this, can I do that?
Yeah, you can just deploy the private network and it works. But the problem with that is the reason the Ethereum Plasma is begging or trying to latch on the mainnet, because mainnet, the point of mainnet is the trust. So we trust stuff that is happening here. But if you have a private network or any kind of network, we go into the area of the talk before, which Nicola said, is it a testnet, is it a real network? How do we trust those people that run it? Because they can do whatever they want, it's their network and you can confirm blocks. I'm not sure if I...
It's okay. In concepts of private network, I don't have a trust problems because I know the actors.
I mean, if you want a private blockchain, just run Cassandra database.
Yeah, but
It depends.
there's intermittent,
It's not exactly like
stuff
that.
like that. It's not, yeah, never mind.
I'm simplifying. Any other questions? Thank you so much. We're still back on schedule, so the next talk will begin at 3:45. You have about 20 minutes.